Okay, here we are at 1.6, Chapter 1, Problem 6, 1.6. The question is, write line bond structures for the following substances, showing all non-bonding electrons in the process. Okay, pretty simple, pretty straightforward. What they're asking for is for us to draw a skeletal structure. Easy enough. What do we have here? We've got a carbon, we've got 3 chlorides, and a hydrogen. Well, we know carbon's the central atom. We know we have a chloride, and a hydrogen. Each chloride, remember, has 7 valence electrons. Let me just fill those in right now, tedious as it may be. And the hydrogen is set with its 1 valence electrons. Now, just to double check, if you want to double check these, this has no formal charge, no plus or minus, no resonance here, nothing like that. So it's just a simple skeletal drawing here. But let's make sure that we have the correct amount of valence electrons. We have 3 chlorides. Each chloride is worth 7 valence electrons. That gives us 21 total. We have 1 hydrogen. Each hydrogen is worth 1 valence. That's 1. And we have 1 carbon. Each carbon gives us 4 valence, and that's good for 4. So we've got 22 plus 4, 26 total electrons, valence, that is. Well, let's do the math. Let's count them up. We've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 19, 20, 21. This hydrogen makes for 22, and this carbon makes for 4 more, 1, 2, 3, and 4, and we get our 26 electrons. Very good. Let's move on to B. We've got a linear here, and we're not going to get into the whether it's linear or trigonal planar or anything like that, because it's not asking us to. So we're just going to go ahead and draw the structure. Now, sulfur is in group 5, and that means we need 5 valence electrons. Lone pairs count as well. 2, 4, I'm sorry, sulfur is in group 6, my bad. 2, 4, 5, and 6. Here you have it. This counts for 1, this counts for 1, 2, and 2, for a total of 6. You've got an octet, full octet here. 2, 4, 6, 8. And you've also got an octet. Remember, hydrogen needs an octet of 2, which you have 1, 2 in this for this hydrogen, and 1 and 2 for this hydrogen. So these octets are good. This octet for sulfur is good, and you are good. The valence electrons are good. I forgot to go over the octet here, but you can see everything's full here. Your carbon has 2, 4, 6, 8. Your chloride has 2, 4, 6, 8. Each one has 8. You're good there. All right, let's go on to C. What we've got here is a nitrogen, carbon. We have a hydrogen, and a hydrogen with a nitrogen here. And this has 2 hydrogens stemming off of it, like so. Time to, by the way, we've got 2 valence electrons here. All right, let's go ahead and figure this out. We have 1 nitrogen. Nitrogen has 5. So we've got 5 times 1. That gives us 5 valence. We have carbon, 1 of them. That's worth 4 valence. That gives us 4. And our hydrogens, 1, 2, 3, 4, 5 hydrogens. 5 times 1 equals 5. Okay, that gives us a total of 14 valence electrons. Let's go ahead and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. We're good. Now let's check the octet. We've got 2 on each hydrogen. We've got 2, 4, 6, 8 on this carbon. That's looking good. 2, 4, 6, 8 for the nitrogen, and 2 for each of these hydrogens, and we are looking good. Done. Let me go ahead and erase this as quickly as I can. Make room for the last one. Okay. We're doing the last one, right? I think we are. Yes, we just did this one. Okay. Again, pretty simple, pretty straightforward. We have a carbon with 3 hydrogens and a lithium. This lithium is in group 1. So this lithium has a double bond. Oh, I'm sorry, it's got its bond here, the octet, which is a 2. And these hydrogens as well have 2. The carbon octet is 2, 4, 6, 8. That's good. And the valence electrons, 1, 2, 3, 4. For the carbon, we're good there, and each hydrogen has 1. The lithium is in group 1. That has 1 as well. You can do this if you'd like, but we really don't need to. We've got 1 there. 3 hydrogens here gives us 3 times 1 is 3. 4 valence altogether. 1, 2, 3, and 4. We are good. Hopefully that gives you an idea of what they're looking for in that problem, and I'll see you on the next one.